HVAC 360, episode number 63. Lessons learned. Geothermal heat exchange. Hey, welcome back, everybody, to another episode of HVAC 360. I am your host, Matt Nelson. Thanks for joining me. Thanks for tuning in again. Glad you're here. Hey, this week I'm going to be going back into my reservoir of different field experience that I have. This one specifically focused on the geothermal heat exchange, and we'll get a little bit more into that. But first, I want to thank our sponsor. Our sponsor for the HVAC 360 is the Building Commissioning Association. You know, I mean, if you're involved in the building commissioning field at all, the one place you want to go to is the BCA because that's the place to network and learn. Speaking of that, the National Conference on Building Commissioning is going on coming up here real soon, May 6th through the 8th. So it's just a couple of weeks away. Denver, Colorado. And, get signed up for that now. Get your plane tickets, get everything organized, and attend that. That is your place to be. That is your place to connect and learn more about building commissioning. It's 100% about building commissioning, so you're not really getting any higher learning density than at the National Conference of Building Commissioning. So aside from that, if you can't make that, we have their spring webinar series is underway. We just passed the first one on variable refrigerant flow. Here, but they have one coming up on May 15th that's control loops tuning and night setback. Is it really that hard? That's their one that's coming up, and that's coming up May 15th, like I said. So for any more information about the BCA, you get their free newsletter, sign up for it. It's called the Checklist. Sign up for that online. But you want to, or even to join BCA, go over to their website. It's bcxa.org. That's bcxa.org. And again, a heartfelt thank you for sponsoring HVAC 360 goes out to the Building Commissioning Association. So now into the topic of today, which is going to be the geothermal heat exchange systems. Now, there's a bunch of different ones you can do, and this is focused more on commercial than residential because obviously that's my focus in business. But the commercial aspect of this, you could do a number of things. It could be involved in a big body of water where you're using that as a geothermal heat exchange. You can do it as a vertical or a horizontal loop. This one is going to be specifically focusing on the vertical borehole. You heard me right. It's vertical borehole. It's a borehole, and that's really the nomenclature. When I started getting into first learning about these heat exchange systems, and again, I say geothermal, but it's not like underwater geyser or a geyser with steam and things like that. We're not necessarily pulling heat from the ground. It's more or less using the ground as a heat sink. So that's where it's the heat exchange, sometimes referred to as the ground loop heat exchange system. It's really kind of, you're taking a place of heat rejection, and it's using the ground and that constant temperature of the ground to be able to accomplish that. But again, getting back to the borehole, a lot of times people get confused. They'll talk about well fields. Now, in the U.S., it's we get very particular about wells because if you're going to drill a well, there's going to be certain regulations, and the U.S. EPA keeps close tabs on that. So we want to stay away from the word well. So we call it a borehole. I mean, obviously, I think that it's important to note that this is not a well. We're not getting water from it. We're not intending to leave it open. We're going to, drill it. We're going to stick a tube in it, and we're going to fill it with bentonite and use it as our heat exchange system. So call it a borehole on your drawings. Label it as a borehole. We've had there's situations where if the EPA got a hold of it and there's 50, 100 wells on a project, they could actually say, you know what, you owe me money to drill each and every one of these wells. even though you're going to fill it, it's still one of those things, one of those hassles that you don't want to have to deal with. So if you're reviewing drawings, tag that on the drawing and make sure that you correct that out in the field. So getting back more into, there's really two things that I want to focus on and share with you in regards to this heat exchange system, and that's really the layout in the field and the connection to the building. I think those are really the two critical pieces that I want to bring my lessons learned forward into this. The first one, obviously, first and foremost, is the design. The design is critical. You're going to do your load calc on your building. You're going to understand what the load is on that, but you need to know exactly what your well field can do. Now, there's great software out there, and I think the one most popular is referred to as GLE Pro, and that's it's what actually GLHE Pro software. It's actually produced by the Oklahoma State University. Now, I guess if there's somebody who knows anything about these ground loop heat exchange systems, it's going to be Oklahoma State University. They've done a lot of research. They've done, the software. They really know it. But really what that software is, gives you the capability to understand. It gives you the ability to understand exactly, what kind of spacing you're going to look at, what kind of, what region, what kind of factors, and it'll be able to take you through all those design configurations. It's also going to be able to, kind of predict exactly where the ground is going to be at in, 40, 50 years. Because what tends to happen is that, when you first use, just like any other piece of mechanical equipment, it has a great reaction when you start using it as a heat sink day one. But when you get to year 40 or 50, it's going to be a little bit less resilient than that. That's at least from my understanding what happens with the ground, and depending on the spacing, because of obviously everybody has their different site configurations, site restraints that they need to configure in their plan. Those are some of the things that can come up. Now, you may not be doing this yourself. You may need to get a third party involved or subconsultant to be able to do this. But I think it's very critical to understand exactly what you're getting into. If you haven't heard of GLE Pro before, I'm going to have go to the website buildingx.co, and in the show notes for episode number 63, there's going to be a link to the GLE Pro site, so you can take a look at it there. All right, so once you have the design all set together, and I'm not going to actually, I'll touch on a few points with the design just from a commissioning perspective, just kind of broad brush, what to look for. Obviously, one of the things, is that they've done this analysis of the field itself, and to take a look at that and make sure that you understand and that they've done this kind of long-range survey and plan of their field. So, but you want to take a test bore. Now, this is really something that, just like you're going to do some surveys for your foundation work for a building, you're going to have to do a test bore for the actual field itself. Now, a couple of things that are important for this. You want to be able to position the test bore in a location that you're going to be able to reuse. You don't want to necessarily put it out way beyond where you're going to put the rest of the field. You want it kind of somewhere where you can kind of use it as, as one of the spots. So you're not drilling for nothing. But what's that going to do for you? That's going to give you two pieces of information that are going to be critical. First off, it's going to say whether or not you can actually do it with your site. Some ground just isn't very conducive to using, you may want to use it you may want to use this system, the ground loop heat exchange system, but your ground might say, nope, you're not going to get the kind of results that you're going to need to do it effectively, cost effectively. So you may have to just bail after you do your test bore. So what you're going to get out of the test bore is you're going to get the amount of heat transfer in one of your boreholes. So that's going to be able to tell you, kind of multiply that out times the whole field. That's going to be able to give you your your heat exchange capacity for the loop. It's also going to give you an idea of exactly what you're drilling through. You're going to have some sort of a drilling log that you're going to be able to get through that. That's going to be a critical piece of information that you want to put in your documents, because whoever is going to be bidding on drilling this is going to be wanting to know exactly what they're going to drill through. There's a lot of different conditions that are great for drilling. One of them I heard is something that's consistent. A lot of times you may get into an area where you're just drilling through a bunch of different random stuff, and that's not good, because you like to be able to at least use a certain technology or process, at least when you're drilling, and you want to be able to stick with that. To change processes is really difficult, and different processes are favorable to different types of ground material. I'm not going to go too much into that, but it's different if you have kind of sloppy soil versus very hard soil. So if you kind of have swap back and forth between those two, it's not going to go out too well. But you'll know that with a test borne. Obviously, that's an important piece of information. So once you have that piece of information and you got the green light, you're saying, all right, the ground loop heat exchange system is going to be the one that I want to be able to use for this. You want to be able to place the dots. You want to be able to place the dots around the site, and that's going to be something that's going to be critical to be able to place the field. A lot of times you're going to end up putting it under a parking lot, putting it under maybe a good area might be if you have for a school location, if you have a playground, or if you have some sort of ball field where you have or soccer field, someplace that you could, if it you end up disrupting it, that would be the best. If you had to do it under your parking lot, so be it. But you're not going to want to build anything permanent over this bore field. So that you want to be able to select your location carefully. So what you want to be able to do is you want to be able to space those about 20 feet on center. You really don't want to have to, that's a good rule of thumb, and you get good interaction from there. If it's any closer than 15 feet on center, you're going to start getting you're going to start affecting or interference. You're going to get interference for performance between the boreholes. And what that means is that the borehole kind of takes about 7.5 feet around where it's at, and that's like the ground that it rejects the heat to and accepts the heat from. So that's kind of the spacing that you want to, the bare minimum that you want to. Now the depth of it is another issue. I typically you see anywhere from 100 feet to 150 feet, 200 feet. I've even seen ones that are much deeper than that, but you want to be able to kind of make sense of that and do that in your evaluation. But those are going to be the two typical variables for your layout is going to be the spacing and the depth. And you want to make sure that if you're checking this, that obviously your capacity of your test bore multiplied by the field, that gives you the same capacity as you need inside your building. Plus a little, obviously a little safety factor wouldn't hurt you there. Next, you want to be able to connect the dots. This in a layout is going to be very critical. This is not rocket science, and if you have no idea or if you've never laid out one of these, talk to somebody who is involved in laying out the piping. There's a couple different contractors typically that I see when you're dealing with these ground loop heat exchange systems. You're going to have the person who drills the holes because they're very good at drilling, but they don't necessarily install the pipe. But there's going to be the people who install the pipe. Those are kind of the people that you want to actually talk to, get a handle on it, understand exactly what kind of system makes sense. Because I've seen some engineers lay it out, and it was just it stuck out. They really, you typically want to be able to lay it out in different circuits. You want to be able to have like a reverse return, so all the different boreholes, vertical boreholes along that circuit have the same pressure drop, and it's all coming back to a main header. So it's easily balanced, self-balancing kind of thing. So that's kind of what you want to see out on the site. is that sort of layout. Now, the one thing, when you take these all back and you connect them to that header, typically you're going to have either one or two options. You're going to either have a vault or you're going to take it with inside the building itself. Since you're going to have a different, construction schedule, this is going to be one of those wild cards when you're actually building the building. Is how the building is going up, how the foundations are being poured, how is that, how's the structure and your tie-ins with all these different, pipes coming into this the building, because you're going to have, a bunch of different set of pipes. Could be upwards, 12, 14 different pipes, because you have a supply and return to each one of the circuits. If you have 7 circuits with a bunch of different boreholes on them, that's the number of pipes that you're going to have, and these are going to be 3 to 4 inch pipes. PVC pipes, or not PVC necessarily, but you're going to have plastic piping, HDPE kind of piping that you're going to have going throughout the system. So if you're going to have a vault, and I've seen that, and that it makes a lot of sense in a lot of cases, don't go with anything custom. You can talk to the vault manufacturers. I've seen that done in a couple of cases where somebody called out a custom vault, and it was really, really expensive, and the lead time was a lot longer. But you can get a standard vault for these geothermal heat exchange systems. Go with that. That's my recommendation. As far as the other thing is that when you're dealing with this different construction schedule, you're going to be able to drill you're going to be able to drill the boreholes and go around, lay the piping, and you're going to there's going to be certain locations, depending on your site, that you're going to want to protect this piping. If you have, say it's a soccer field out for a school, for example, and a lot of these I've done were for public schools. So you're going to end up having this field, and you're going to have the return pipes come around back to the building. You want to make sure that you protect that, because what you're going to have is you're going to have a lot of construction traffic around that perimeter of the building, and you're going to have these JLGs, these big, monster trucks, these cranes, kind of going around the site. I've had cases where they've literally cracked the piping, and you got to dig it up, you got to repair it, you got to go from scratch, put some plates over it, have that kind of protection in the drawing, so you're not damaging the pipes after they've been laid. But there's going to be a lot of construction going around, after you've done all the piping work for this ground loop heat exchange system. So you want to be able to protect those as best you can. Identify the areas that are going to be high traffic, that are going to be carrying a lot of weight, so you're not getting crushing. Now, another thing that you want to be able to do is you want to not only protect it from site traffic, but you want to protect it from the burial material itself. You typically, when you have this plastic piping that's going through and serving the heat exchange field, you want to be able to bed it in some sort of sand material. If you just bed it in gravel like you would ordinary pipe, there is a tendency for this pipe to move and react and shift, even ever so slightly. If you have a gravel that you're bedding it on, it's going to kind of go back and forth, kind of in sawing motion. You could end up springing on a leak somewhere in this field. That's going to be pretty tough to find. Now, speaking of finding it, obviously, whoever drills the holes and lays out the piping, you're going to want to be able to identify that. So another critical component in laying out the system is being able to get it tagged properly. You want to be able to put tracer tape, just like you'd identify any sort of utility line. You want to be able to identify where the first borehole is and the last borehole is in a circuit. So you want to be able to grid this out. So being able to identify those specifically, that kind of it gives you kind of a matrix on where exactly everything is laid. I've had a couple cases where they've in one of the circuits they've lost pressure. There was a lot of leaking, and they were able to identify exactly where in that circuit they had. They were able to identify the length of run, And once they got it done there, they don't know exactly where the leak is. If they know it's in one particular circuit, in one particular line, but they'll start digging and they'll kind of try to find as quickly as they can. And it's a matter of luck then where is it leaking. A lot of times what you're going to find is that it's not going to leak down in the vertical borehole itself. It's more or less going to leak somewhere around, either the top of the header or the top of the borehole where it comes out and bends around and connects into the branch circuitry or the branch circuit piping. Or it's going to be somewhere along that branch circuit piping. It's going to be, somewhere around there. So, not to say that you're never going to, have a borehole clog or that you're going to have to, cap that off. But typically, in this piping layout, it's really, once you get from that header and those valves on the header out into the field, there's nothing there but just plastic pipe going back and down. So there's really, very little resistance, very little, valves that you could check on or anything like that. So it's something typically going to be with the pipe. So tracing it and being able to tag it properly, those are important things to get specified in the details and make sure they're installed. So now that's pretty much what I have for the field. For the connections on the building, there's a couple of different ways. You have to be careful because you have this building system and you have the ground loop heat exchange system, the geothermal heat exchange system, and it's kind of they're two entities really. You're going to have the mechanical contract. It's kind of like when you look at designs. Typically, engineers say 5 feet outside the building, it's not mine. It's more of the civil engineers. That's their domain, and they'll have that split at that 5 foot mark. Well, it's the same thing that kind of happens with contractors, and it's very important for engineers to know this because unlike the most of the civil work, I think the mechanical engineer, is going to be very interested in laying out and identifying the geothermal heat exchange, even though it's out in the field. Well, the problem is that inside the building, it's the mechanical contractor and their work, and outside in the field, it's going to be a driller and some sort of another company another contractor that's going to be doing all the piping work. So you got to be able to delineate exactly, okay, who does it when? Are the driller and the field guy, the site work contractor, are they under the mechanical contractor? You want to make sure that there's this understanding of where these divisions lay, where one contractor stops and another one starts. So when you get into that building, exactly where, you have to be able to delineate that on the drawings and get that all squared away for a couple of different reasons. But the one thing I wanted to point out, when you get it into the building, obviously it's going to be one system. You want to be able to do a couple of different things. You want to be able to not only circulate kind of on both sides of this, one side on the outside, one side on the inside. You want to be able to circulate them independently of each other. There's a lot of gunk and gook that gets into the pipes, or there's a possibility of that. You want to be able to kind of isolate that from a lot of the heat pumps that are on the inside of the building. And typically that's what you're going to find heat pumps on the inside of the building. So you want to be able to isolate them. And typically, that's done with a bypass valve and a couple of sets of valves on the supply and return to kind of, you can play around with isolating one side or the other. You also want to make sure that you have ways to fill the two systems independently, fill or drain the two systems independently. And that's the kind of the next thing. Who fills the system and how? There's certain situations where I've seen where they've actually isolated the two systems by putting a heat exchanger. So your fluids of the outside doesn't mix with the fluids of the inside. That sometimes works. Sometimes the heat exchanger, might get a little bit gunked up. I mean, there is that possibility of, sediment and things like that. affecting that. I mean, you're going to take a hit as far as efficiency goes, ever so slightly doing a heat exchanger, but sometimes, that's the way to go. So that's really a design decision that I'm going to leave to the engineer to let him make that. Otherwise, you also want to be able to say, what exactly are you going to be able to fill the system with? If you're going to use the same system, are you going to use glycol? I've seen glycol used, and I guess a word of caution: if you've read anything about the on the blog or about the blog, or maybe even another episode that I've mentioned this, but obviously you're going to have your choices between ethylene glycol, propylene glycol, and I have also seen like a methanol used, which is more of an alcohol-based solution. And again, it's critical that you work with the facility that this is being installed in, because they're going to have the expertise and the knowledge to be able to handle these different types of chemicals. I mean, they're all chemicals. I know that, at least typically, one of the things, ethylene glycol, a little bit more harsh and restrictive as far as what we can do here in the States. Propylene glycol, a little bit more forgiving, but still it is a chemical. So if you spill a lot of it, something needs to be done. And obviously, methanol is the same sort of thing that you need to factor in. Get that training, appropriate training, and get it taken care of. But who provides that and how they provide it? That's something that needs to be discussed and configured, whether or not you are going to have a premix solution that comes to the site, whether or not you're going to have just barrels of this stuff being pumped in after you've done the flush and fill. How exactly is it going to be done, and who's going to be doing it, and who's going to be responsible for taking this responsibility part of the project, because you want to be able to actually marry the two systems together, the outside and the inside, and make it go smoothly and have it work. So that is some of the things on the inside. Now, you might want to be able to add something in the future. You might want to have a hybrid system where you're going to add some sort of fluid cooler, cooling tower to the cooling capacity. Sometimes you're going to need a little extra oomph, or your system may need in the future. Like I said, it's going to deteriorate over time. How much is really not known, but you want to be able to kind of plan for that in the future. So if you have a place to connect, some sort of supplemental cooling, you can do that when it gets really hot out. Or conversely, you want to be able to say, hey, you know what? Am I going to need additional heat in this system? You may want to add a boiler, and that's a different sort of a set of situations. So how are you going to connect that? Where are you going to connect that? Those are some of the things that you want to think about when you go through this kind of system. So that's pretty much all I wanted to go through for this ground loop heat exchange system. I've seen them work well, and I've seen some disasters, some train wrecks. And it's really kind of important that you know about this. I guess one thing that pops into my head, and I know there was some issue with a particular job. It wasn't anything that I was working on, but I've kind of heard this second or third hand. But it depends on you got to make sure that you're using the right kind of fill, and by fill I mean whatever liquid you're using to fill your system with. You got to have that kind of straightened out. I mean, sometimes I think that there's some people who say, hey, you got to use very refined water, purified water, what have you. And some people say, hey, you know what, just use the tap water. But the thing is, if you start mixing and matching and you don't take a careful look at what exactly your system is capable of handling, you may end up mixing the the antifreeze solution and glycol. And in one case, I think it was that they used either well water or water that really hadn't been treated. They combined it, and it really turned into the kind of the slurry that was really sort of harmful to the system. So they really had a great deal of problems trying to get that one cleaned up, and that wasn't anything that was very nice to deal with. So be careful what you're filling the system with. All right. Anybody have any more questions? Feel free to send the emails to me. Get my opinion on this, that, or the other thing. But I just want to be able to kind of pass on some of the things that I've learned out in the field that have been impacting. And obviously, all these things are things that have happened to me and situations and questions that have come up. So I'm just kind of passing those on, passing them forward. Hopefully, if you learn something, pick something up. If not, a lot of information that I've gotten came specifically from conversations I've had with people who've, contractors who've done the piping layouts of the drilling. Also, if you go to the heat pump manufacturers, talk to some of the manufacturers' reps that are local to you. If there's any that are any good, they can definitely help you out on some sort of education, and maybe you've seen that in the past, and maybe you can take advantage of that in the future if that's something that you're interested in. So, all right, I want to thank you for listening, everybody tuning in. It's been great. I enjoy, if you're new to HVAC 360, welcome. If you're a longtime listener, I really appreciate you sticking in there and listening every week. Obviously, if you like this episode, please pass it on. That's really the best thing you can do for me. Again, thanks to the Building Commissioning Association. I really appreciate their support. Also, if you want to leave some feedback or give me a star rating, hopefully preferably 5 stars, on iTunes, you can do that. I know I had just one recently, and all I remember is Commandante. But I appreciate your comment, and I will kind of get you a shout-out for the next episode. I'll have to get that in the show notes so I can remember next time. Also, hey, I've gotten some feedback as far as anybody any friends that that have or listen to, they're stuck with an Android phone or somebody who's on a BlackBerry. I've just recently been approved for the BlackBerry Podcast Store and for Stitch, which is a app that you can actually get on iTunes, or it's available on the Android store. So Stitch, you can get HVAC 360 now for your Android phones if you want to make it easier for you. And that's I'm really appreciate that heads up that I got, and I want to be able to kind of lay that out there for people to kind of share HVAC 360 with the world. I really appreciate it. Again, if you want to email me, it's matt@buildingx.co. If you want to go to the blog, it's Matt, or it is buildingx.co. Otherwise, Twitter, @buildingx, or on LinkedIn. You can always connect with me there. Matt Nelson, PE, at LinkedIn. Yeah. So, hey, everybody, I appreciate that. And remember, as always, know what you build and share what you know.